Okay, is my screen shared now?
Yes.
Okay, now we can start with the Griebatch normal form, right? So here, what is Griebatch normal form? So here in this normal form, all the productions will take this form, okay? A derives B, or A derives B, C1, C2, C, right? So this is the format. So where A, C1, C2 are the non-terminus and B is the terminus in it. So please make a note. Please do differentiate between the Chomsky and breakbacks, right? So here in the case of, hope you can recollect the things, right? So in the case of Chomsky form, I can either have two non-terminus or only one terminus in this. So whereas in the case of breakbacks normal form, here we'll be having only one non-terminal, or sorry, only one terminal, or it should start with the terminal and can have a sequence of non-terminals. Okay, start with the terminal and can have a sequence of non-terminals. So this is the that's normal form. Yes. Okay. In order to start with the Greenback's normal form, again, your grammar should be a simplified grammar, and then your grammar should be in CNF. Okay, so the grammar should be simplified, and then this is the first step, simplification of grammar. Next comes the converting the grammar to CNF, and then we have to proceed with the Greenback's normal form. So here I'm discussing with the perspective of exam point of view. So for exams, you will be given with the grammar which is in CNF. Uh, from that, you will be in a position to convert. You have to convert into Greenback's normal form. Okay, so in general, if I want to convert a grammar to Greenback's normal form, then first I have to proceed with simplification, then converting to CNF, and then to Greenback's normal form. Okay, now we are going to start with an example. Okay, so here, yes, first two steps already discussed. Okay, so we are taking a grammar which is in CNF, and then we are going to proceed with converting that grammar to Greenback's normal form. Okay, so let us start with an example. Okay, so this is this grammar in Chomsky normal form?
Yes, ma'am.
Yes, good. Yes, this is a Chomsky normal form. Okay, so now we can start with the steps involved here. So first step in converting the Greek maths. First step in the sense I'm leaving the first two steps of simplification and converting to CNF. So with the, after that I'm talking of the first step, right? So first step is that we have to rename all the non-terminals into some AI. AI in the sense you can go for any naming convention like this. Okay. So here first step is change the names of the non-terminals into some AI where AI is in ascending order. Okay, I have to rename it in like this where AI is in that is it should be in ascending order. First, I have to rename it as A1, then the next variable as A2, next variable as A3. Likewise, it goes on A1, A2, A3, A4. Likewise, it goes on. Okay, so like that, we have to proceed with renaming. So first is going to be renaming of variables. So here we can start with. So here with the first variable name is yes. Okay, so here yes, I'm going to rename it as A1. Next variable is okay. So I'm going to rename in this order. Okay, rename in this order. So because I'll be checking with the condition where okay, we can deal with that condition later. Okay, so the next non-terminal is C. So let it be named as A2. Next non-terminal is A. Named as A3. Next non-terminal is B. Named as A4. Okay, so we can start with, so here A1 derives. So just I'm going to rename the non-terminals, that's it. Okay, in ascending order. Okay, So A1 derives A2, A1 or A4, A2. A1, A. Okay. Are you clear till this point?
I'm on the first one, that's A2, A3. In the first,
Where now?
A1 derives A2, A3.
Yes, 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 yes. Okay, so we have renamed. Okay, so after renaming, the next step is to make some changes, convert that into prefix. So here, if there is a production of form, so please make a note over here. If there is a production of form, AI derives AJX, then it should be I less than G. If consider and having a production like then this condition should be satisfied. Okay, so because of that only we have renamed like this. Okay, so first is one, next is A2, next A3, like as we proceed with. So AI derives AGX. So if I am having a production like this, then I should have I less than G. Okay, that is I should not be greater than or equal to J. If it is greater than or equal to J, then I have to substitute, that is I have to make changes such that I'm reaching this condition. Okay, I greater than or equal to J should not be there. This condition should be met. Here we can start with, yes, here you can see, yes, in this production, this condition is satisfied, right? This condition is satisfied. And similarly, here also this condition is satisfied. This is I, this is J. Okay, I is less than J. Here, yes, I less. So here, what is the A4 derived? Is the condition satisfied over here? This is I, this is J. So here, I is greater than J, right? I is greater than J. So what should I do? Productions of A1. Productions of A1, I have to place it here. Okay, productions of A1. So what are the productions of A1? This is the production of A1. So A4 derives B of what is A1? This is A1. So A2, A3 or A4, A4, A4. Okay, so this I can rewrite it as B or A2, A3, A4 or A4, A4, A4. Okay, so please see here what we did. First, we have renamed all the non-terminals in the form of A1, A2, A3 like this, right? So in the ascending order, we perform the renaming process. After renaming, this grammar is rewritten test, right? And then after rewriting it, we check with this particular condition. That is, if suppose I'm having a production like this, non-terminal, right? So if I'm having a production like this, then this condition should be satisfied. If the condition is not satisfied, then I have to appropriate changes. So here you can see the condition is not satisfied. So what I have to do, productions of A1, I have to place it here. So on placing it here, so I'm getting this one. Okay, I'm getting this one. So what happens is, so here it is satisfied, here it is satisfied. That is, again, that is deviation, right? So here, what should I do? Yes, productions of A2. What is production of A2? So please make a note over here. Here A2, A3, A4. So here it is not again satisfied. So what should I do? I have to replace production of A2 here. So it is going to be A4 derives B or B, A3, A4, 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 A4. Okay, so here this is going to be this is the current status of the production. Okay, so here yes, this is in Greek backs, this is in Greek backs, whereas this is not in Greek backs, and again it is not meeting this particular condition, that is I is not less than A. Instead here I is equal to J. So here I is equal to J. So here A4, here A4. Okay, so please make a note over here. So this is A4, this is A4. Same thing. Okay, equal. This is called as left recursion. That is the non-terminal is calling itself. Okay, this is called as left recursion. Okay, so let me repeat. So here I'm having A4, here again I'm having A4. That is I is equal to J. So if I is equal to J, then we will be coming across the left recursion. This left recursion needs to be eliminated. How I am going to eliminate the left recursion? So we must to make a note of this. Just to make, we are going to just make use of this rule. That's it. Okay. A derives A alpha or beta. Okay, so here you can see this is A, this is A. Yes, that is left recursion. If we are coming across a left recursion, that needs to be eliminated. For eliminating left recursion, we are going to introduce additional non-terminal. Let me call that non-terminal as A dash. Okay, A dash derives alpha A dash or alpha, and A derives beta A dash or beta. Please make a note. This is a rule. This is a rule. So we have to make note of this rule and just we have to apply it. Okay. So here there is left recursion. Here there is left recursion. So I have to eliminate it. Okay. How I'm going to eliminate this? That is what we are going to see. A4 dot A4, A4, A4. I have to map this production with this production. Okay, map this with this one. Okay, so here A. So this is A, and this is A, and this part is alpha, and this part is beta. Okay, so whichever component that comes with that non-terminal is called as alpha, and the rest of the production is called as beta. Okay. That is what we are doing here. So here A4, A4, this is left function. So that is designated by C. Just I'm mapping this production with this formula, with this one. That's it. Okay. So what should I do? I have to introduce an additional non-terminal, that is A dash. So here A we are calling, here we are running A4. So I'm going to introduce A4 dash. A4 dash device. Please make a note over here. Here, instead of A4 dash, you can go for any of the non-terminal which is not in this. That is any non-terminal. You can go for sorry, what's that? PQZ, anything you can go for. Okay, so just for to avoid confusion and making use of the same non-terminal with the dash. That's it. Okay, A4 dash derives alpha. So which is alpha here? A4, A4. So please note this A4 and this A4 are not same. This is different. This is A4 dash, right? Okay, so A4, A4 dash. And next is A derives. So here A4 derives beta. So here this is beta. B or B A3, A4, A dash matches A4 dash or beta. That is B or B A3, A4. So I can rewrite this as A4 derives B A4 dash or B A3, A4 dash. Sorry. Or B A3, A4. We are clear with this? Or we are clear with the elimination of left recursion?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. So, yes, but that's clear for you. So, but in order to, so somebody,
Ma'am,
yes, ma'am.
ma'am, I had a doubt in the can you speak? Yes, ma'am. In the first one, A4 dash, like A4, A4, A4 dash, there should be or A4, A4 also, right?
I have been seen. Or,
Or
yes,
and in the above line, where we put introduce the yeah, for we replace A2 by B, right? In that A4 is also like I greater than like A3 one part. Why don't we replace for A3?
which one?
No, ma'am, just above that line only. B A3 A4.
This one. Should I scroll down?
No, no, ma'am. Where you
Please.
talk about left recursion, where you introduce left recursion. Yes, ma'am. Yeah, A3, A4, A3 also. We just need to check the first one.
Did I miss anything? Get this point. Let me check. Here,
Yes, ma'am. So here, like 3 is also less than 4, right? So we just need to check the first terminus only, non-terminal only.
yes, yes, yes. Only this
Okay.
term.
Okay.
Okay. So only the first term we have to check. Okay.
Yes, ma'am.
Okay. Just we can see one more example for electric recursion, which is not related to this example even. Okay. We can take only one more example, and then we can further move on with the Greek bars. Okay. So just one example, but this is for electric recursion alone, not with Greek bars. Okay. So let me take this one. We derives E plus T or T. Right. So here, this is left recursion. So here, the function. So as you all aware, recursion is nothing but function calling itself, right? So here, non-terminal calling the same non-terminal. So this is left recursion, the leftmost term. So this is A and this is E. The component that comes along with that term is designated as alpha. So this is alpha and this is beta. So how should I rewrite it as A dash? So here B dash derives alpha. So what is alpha here? Plus T. E dash or alpha plus and then B derives beta A dash, which is beta here T. In E dash or T. Hope it is clear for you all now. Right? Shall we proceed?
Yes, ma'am.
Yes. Okay. Okay. So here we have completed till this point, right? So now we can, yes. So we can rewrite the rest of the thing. So here what is, so A1 derives, I'm just going to rewrite all the productions we have discussed at this point. That's it. So A1 derives A2, A3, or A4, A4. Then A4 derives B A4 dash, B A3, A4, A4 dash, A4, A4 dash derives A4, A4, derives B and A3 derives A. Okay, the same grammar, I'm just again rewriting that's it. Okay, so this grammar we have in this particular production we have made some updations because it is deviating from the given rule. After changing that into this, satisfying this rule and rewriting it. So here, when we see here, all the this. Here you can see all the productions. Yes, and having productions of the form AI derives in JX where I is less than J. Yes, one is less than 2, one is less than 4. Yes, this is different, this is different. So please make a note. This is A4 dash and this is A. Okay. So here again is all the productions in Griebatch normal form. What is Griebatch normal form? It should start with either I should have only one terminal symbol or it should
Or
start
should
with the
start the
terminal. Yes. So here, this is in Griebatch, this is in Griebatch, and this is in Griebatch. In the rest, there is deviation. So what should I do? So here you can see instead of A2, I should place the productions of A2. And here instead of A4, I should place all the productions of A4. Okay. So here A1 derives, just rewriting it. That's it. Okay. So A1 derives B A3, yes. So production of A2 is B, so B A3 or A4 A4 dash. So what about the productions of A4? This is the productions of A4 which needs to be multiplied with A4. So let me proceed with multiplying with each and every component. Okay, concatenating with each and every component. B A4 dash A4 or B A3 A4 A4 dash A4. Just I'm concatenating A4 with all the productions. That's it. Okay. So B A4 or B A3 A4. So now you can see all the productions are of Griebatch normal form. Okay. So yes, so the next one is already in Griebatch normal form. This is in Griebatch normal form. Next you can see, yes, if we talk of A4 dash. Yes, it is not in Griebatch normal form. What should I do? All these components should be concatenated with A4, A4 dash. That is, instead of A4, I should place all the productions. Okay. So instead of A4, I'm going to place all the productions. So B, A4 dash, A4, A4 dash, or B, A3, A4 dash, sorry, A4, A4 dash, again A4, A4 dash, or B, A4, A4 dash, or B, A3, A4, A4 dash, or so this is over. Okay, so this is over. Next, what should we do? So we have to rewrite this also. Okay, this also should be converted to Griebatch normal form. So for converting, I have to place all the productions of A4 here. So or B A4 dash A4 or B A3 A4 A4 sorry A4 dash A4 derives B. Are you clear with this?
yes, ma'am.
Yes. Okay, just let me give an overview of this. That's it with the Griebatch normal form. So it is very simple when compared to the rest Chomsky. Okay, so just we have to apply the rule. That's it. So here in the case of Griebatch normal form, the grammar should be first before proceeding with the Griebatch normal form. We have to make the grammar as a simplified grammar. So first it should be a simplified grammar. And the grammar should be in Chomsky normal form. Okay, so after that only we can proceed with the conversion to Griebatch. So what is the first step? We have to proceed with renaming. So while renaming, please make sure to rename in this fashion. So because we have a rule where we will be checking I is less than. So if there is a production of form AI derives AJX, we'll be checking for the pattern where checking for the condition where I is less than J. So in order to consider that, we are renaming in this fashion. Okay, so even any form you can rename. So in that case, we'll be in a position you have to make the appropriate updations. That's it. Okay. So here, yes, we are just renaming as A1, A2, A3. That's it. Okay, and then we have to check for this condition. If this condition is not satisfied, we have to make the appropriate updation. So how we are going to perform the updations? So here we can see there is a deviation. That is I is not less than J. So what we have to do? Productions of A1 should be placed here. That is what we are doing here. Productions of A1 are placed here. Okay. So if there is, so here this is the scenario if I is greater than J. Okay, this is the scenario if I is greater than J. So if I is equal to J, then it is called as left recursion. I is equal to J, then it is called as left recursion. How to eliminate left recursion? This is the rule for eliminating left recursion. We have to introduce a new non-terminal to eliminate the left recursion. Okay, after eliminating, so after dealing with all these steps, we'll be having all the productions with the form where I is, that is, if there is a production of form AI derives AJX, I will be having the value of I will be less than J. Okay, so that condition will be satisfied. So after this condition is satisfied, and then now we have proceed with converting to the final step, converting to Griebatch normal form. That is, we have to make the first term to be a terminal symbol. So appropriately, we have to proceed with the updation. So here we can see there is a deviation. So productions of info are placed here. That's it. So this is how we'll be dealing with converting the grammar to Griebatch normal form. Okay, so I'll be giving you one question. So please do try solving this, right? So I'm sharing a question in the chat box now. Okay, so all the productions is again. Please make a note over here. S derives AY or ZA or AZ or B. Please make a note over here. So here that or symbol is missing. So please make a note of it. AY or ZA or AZ or B. Y derives Z A derives AX or A, X derives A, Z derives B. Okay. So for this, please we proceed converting the grammar to Chomsky normal form. Is my voice clear to you? Am I audible?
Yes.
Yes. Okay, we are completed. So,
Yes, ma'am.
yes, good. Okay, so here, yes, this is the grammar, right? Yes, just rename it. So please do all, if you are doing with it, no problem. So if you have any queries, so please do see here. Yes, just renaming. First step. So as you are aware, this is in Chomsky normal form. So first step is proceeding with renaming. AS A1, next to non-terminal A2, next to non-terminal A3, next to non-terminal A4, yes, and then X is A5. So after renaming, just rewriting it, rewriting the set of productions. Yes, here you can see one is I is less than J. That is 1 is less than 2, 1 is less than 4, 1 is less than 2, 3 is less than 4. So whereas here comes the deviation. So where we are coming across the left recursion. Okay, so we have to eliminate the left recursion. Yes, already we have discussed the rule. Yes, A derives A alpha or beta. So whichever component that accompanies A is going to be the alpha, the rest of the productions would be the beta. Just rename it. Sorry, just apply the rule and proceed with eliminating the left recursion. Okay. And then yes, after eliminating the left recursion, proceed with yes. I have rewritten all the productions over here again. A1, A3, A2 dash, A2, A5, A4. Okay. So here, yes, all the productions are satisfying the condition that AI less than J. That is, if that is a production of the form, AI derives AGX, then I is less than J. That condition is satisfied. Now we can proceed with the next step, that is all the production should start with a terminal symbol. Yes, so here what should I do? So here we have to replace with the productions of A2. So yes, that is what we have done here. Hope it is clear to you all. Have you all completed?
Yes,
Yes.
ma'am.
Yes, ma'am. Yes, yes, I'll be giving you some set of questions for practice. So please to submit it as assignment. Even that can be used for your practice questions for your CAT as well. Okay. So I'll be giving you a deadline till your CAT exam. So by the CAT, that is my, before that, we complete the task and submit it. All right. Uh, yes, ma'am. That's it with the today's session. So